We're going to start looking at solving systems by elimination. So elimination is a method you use when both equations are in standard form, where we have ax plus by equals c. For elimination to work, everything has to be lined up. Your x, your y equal signs, and then your constant is equal to over here. Okay, so simple elimination is when we already have a pair that cancels out. So we're going to line them up, and we're going to pretend like we were adding the two equations together. And simple elimination, we have a pair that cancels. So if we were to add these together, these cancel out. 2y plus y gives us 3y, and 8 plus 4 is 12. And now all we have left is 3y equals 12. So we can divide by 3, and we get y equals 4. So we know what y is, and then just like all the other methods, then we go plug it back in and find x. Either equation will still work. Either one's typically easier than the other one. I'm going to use this second equation, so 2x plus y, but instead of y, I'm going to put a 4 there now, equals 4. And then we can solve for x. So we can subtract 4, and 4 minus 4 gives us 0, and then divide by 2. 0 divided by 2 is 0. So we get a solution of 0, 4. Okay, so the downside to simple elimination is there's several specific rules in order for it to work. They must have a vertical pair that cancels, like that last one did. In other words, same number, opposite signs. You're always going to add the equations. Subtraction, even though it would work, it makes keeping track of signs very difficult. And everything must be lined up. So another example over here in the top right, these are lined up. And let's see if I make that a little bigger. We got a vertical pair that cancels. We got negative y and positive y. So those would cancel. 6x plus 3x gives us 9x. 5 plus 4 is 9. And we could divide by 9 and get x equals 1. So we know what x is, plugging it back in, and finding y. So I'll use this second equation. 3 times x, so 3 times 1 plus y equals 4. Now we have 3 plus y equals 4, and then we'd subtract 3, and you get y equals 1. So 1, 1 would be our solution. Okay, another example. 2 more examples of simple elimination. These are lined up. X's cancel. Positive x and negative x. 4y plus negative 2y gives us 2y. 9 plus 3 gives us 12. And then we can divide by 2. And we get y equals 6. Okay, so once again, we will then take that and then plug it back in for the y. So I will use first equation. X plus 4 times 6 equals 9. So that becomes x plus 24 equals 9. And then we'd subtract 24. And 9 minus 24 would give us negative 15. So we get negative 15, 6 as our solution. Okay, one more like that. This one, our x's cancel, negative 4x and positive 4x. So negative 3y and negative 2y combine to be negative 5y. Negative 18 plus 8 gives you negative 10. So then we divide by negative 5, and that will give us y is 2. So we're going to go take 2, plug it back in for y. I'll use the second equation this time. So 4x minus 2 times 2 equals 8. That gives us 4x minus 4 equals 8. Then we will add 4. And we get 4x equals 12. And then last, divide by 4. And we end up with x equals 3. So we get a solution of 3, 2. So all those would be what we'd classify as simple elimination. Okay, moving on to the other side. Going to work through 2 more I want to point out on this side, and then the word problem together. And the rest you will have to try on your own. So if you look at number 2 under the classwork, the problem here is not everything's lined up. So before we can do elimination, we have to line everything up. So this second equation is already in standard form. X, y equals constant. So we need to rearrange this one. Oh, help if y'all can see it. So what I was saying is this one is already in standard form, x, y equals a constant. This first one we need to rearrange. The x is on the left, we need to move the y over. So we'd subtract y and have 3x minus y equals 5 now. Now it lines up. So kind of ignore that first one. We're just looking at these two. We have y and negative y, sets up for simple elimination. Those would cancel. 2x and 3x make 5x. 5 plus 5 is 10. Divide by 5 and we get x equals 2. Plug in that back in. Now for this one, I'm going to go back and use that very first one, the one we changed. Because it doesn't matter. You could use the new one we made, any of the two original ones, they'll all work. So 3 times 2 equals y plus 5. That gives me 6 equals y plus 5. Then we subtract 5. And we get y equals 1. So our solution would be 2, 1. Okay, another example just to see one like that again, number 3. Neither one of these is, or I take that back. The first one is in perfect standard form. We got x, y equals a constant. So we need to rewrite this one. Okay, just so we can line them up better, I am going to rewrite this first one down below here, the one that is in good form, standard form. So with this equation, the constant's on the wrong side and the x is on the wrong side. So we need to add 15 to move it to that side. It's going to give us positive 15 on the right, and we need to subtract x to move it to the left side. So we're going to end up with negative x plus 3y equals 15. Now it's lined up. X's cancel. Negative 4y and 3y give us negative 1y. Negative 19 and 15 give us negative 4. And we need positive y, so we change our signs. We get y is 4. Plugging it back in to either equation again, I'll use this second one from the original equations here. So 3 times y, which we now know is 4, so 3 times 4 minus 15 equals x. So I get 12 minus 15, and we get negative 3. So x is negative 3. Okay, so let's look at also now over to number 6, see how it can be applied to a word problem. So a gas station has a car wash. If you get your gas tank filled, then you're charged a lower flat fee X in dollars for a car wash, plus Y dollars per gallon for gasoline. 2 cars fill up with the regular gasoline and both get a car wash. One used 8 gallons of gas and pays $22.80 for the gas and the car wash, and the other car uses 6 gallons of gas and pays $18.60 for the gas and the car wash. So we know that if you get your gas tank filled, then you are charged a lower flat fee X in dollars for a car wash plus Y dollars per gallon of the gasoline. So we know Y is per gallon of gasoline, X is per the flat fee for the car wash. So using that, the first car, 8 gallons of gas, pays $22.80. So we know Y is dollars per gallon. So Y, dollars per gallon, X is the car wash. So for that equation, we got a car wash, X, plus 8 gallons of gasoline times Y, the cost per gallon, equals $22.80. For the second car, got a car wash for them too, and they bought 6 gallons, so plus 6y equals $18.60. So there's your 2 equations. Now that sets up perfectly for elimination. The problem is it's not simple elimination, so we're going to get a little ahead of what we looked at today and kind of give you a preview of what we're going to do the next day with elimination. We need to make it where it's simple elimination. Well, these are both x. We would need one of them to be negative x. So if we just multiply one of the equations by negative 1, that becomes negative x minus 8y equals negative 22.80. Now, sets up perfect for elimination. Your x's cancel. 6y negative 8y give me negative 2y. 1860 plus negative 22.80 gives us negative $4.20. And then divide by negative 2. and you get $2.10 is the cost per gallon of gasoline. So we know our Y. We can plug it back in now and find X. So I'll use this second equation here, X plus 6Y. So X plus 6 times 210 equals 1860. So 210 times 6 gives us 1260. And then we subtract the 1260. And we get 6. So it's going to be $6 for that car wash and $2.10 per gallon of gasoline. Okay, so use that to finish the rest of the classwork and then the homework that's related.